class. Today we're going to look at different properties of the rhombus and the square. So go ahead and track along with your note-taking guides, and I hope this is helpful. So a rhombus is another specific type of parallelogram, and the reason we're starting to list it like that is because all those other properties of parallelograms still apply, but now it is more specific where you have four congruent sides. So other properties of the parallelogram would be like that these sides are parallel. So if you want to like add those in, you can. The opposite angles are congruent. The opposite sides are congruent, but because all four are congruent here, you don't really need that. And the diagonals bisect each other. All of those things still apply to a rhombus, but there's a couple more things, two other properties specifically about the diagonals that also apply. It would probably be helpful if you could draw these diagonals in with some sort of straight edge so that these properties are even easier to see. If you need to pause the video to do that, go ahead and take a second. So I have these diagonals, and you might be able to tell just by how it looks, but not only are the diagonals bisecting each other, and if you just want to write that off to the side, you can. That's just a property of any parallelogram though. They actually do two other things as well. And the first is that the diagonals are perpendicular. So I'll write that down, and I will just draw in the right angle symbol here. If that is in fact a right angle, you have four right triangles, and you got to remember that all of these are the same length. The Pythagorean theorem will come up sometimes for these. And the other property is that the diagonals bisect the angles that they intersect. So these two angles are going to be congruent. These would also be congruent to those up there because the opposite angles are congruent. And those two, and those two, all four of those would be congruent also. So really all you would have to have is one of those angle parts, and you'd be able to come up with everything else. So let's say for example that like this entire angle here is 60 degrees. Well, if that's 60, then each part is 30, and these would both be 30 also. A couple of different ways you can come up with these other ones. You could remember that these consecutive angles are supplementary, so that this whole thing is 120. So that would make each of those parts 60. A different way that you could do this is you could know now that the diagonals bisect, the diagonals are perpendicular, so that would make each of these right triangles, and you could come up with the angles that way also. So down here at the bottom, I'm going to ask that you draw the diagonals in here too, and I'll just show you a way one of some of these examples will look. Whoops, let me do that again. Well, that's kind of messing up like that. Okay, so let's say that they maybe tell you this or they don't tell you that. They don't even need to. They might just have something here that says like this angle is 3x, and they want you to solve for x. Well, if that is the case, you do need to remember that in this rhombus those diagonals are perpendicular. So each of those four angles would equal 90. So you can take 3x and just set it equal to 90, or x equals 30. A different way that this could look is maybe they give you these sides instead, and let's say that they tell you that each of the outside pieces is 5, or they could just mark 1. They don't have to tell you all of that. And let's say that this entire length here is 8, and we want to find, let's just find y, and we'll say that y is this segment here. In order to do that, I'm going to need to know that I need to find this piece, and that's going to be 4 because those diagonals bisect each other. And then looking at this right triangle, I can use the Pythagorean theorem to find that side. So I'd set this up: y squared plus 4 squared equals 5 squared. So y squared plus 16 equals 25. Y squared would equal 9, and y equals 3. So just a couple of different ways that these questions could look for you. To define a square, different people will define it different ways. A square is another type of parallelogram, and you could define it by saying that it has 4 congruent sides and 4 congruent angles. Or what some people do is they just define it as a rhombus and a rectangle, because it technically is both of those things. A square is just a more specific rhombus, a rhombus with 4 right angles, and a square is a more specific rectangle, a rectangle with all the sides being congruent. It's kind of like the hybrid of both of those things. So all of the properties of all of these shapes apply. The opposite sides are parallel, the diagonals bisect each other, the opposite angles are congruent, the diagonals are perpendicular. All of that stuff that we've learned for the parallelogram, for the rectangle, and for the rhombus, all of those apply to the square. So you're going to be asked to answer different questions about these, and we can just do a couple of examples. Let's say that I draw in these diagonals here, and I'm actually taking this example from the book. It says that, let's say that you want to dig a square. You're excavating a site and you want to make sure that this is exactly a square, and you measure and you know that you want each of these sides to be 1 meter by 1 meter, but you don't want it to just be a rhombus. You want to ensure that it's a square. Well, if we measure the diagonals and those diagonals are congruent, then we would know, because that's a property of a rectangle, that it would be in fact a square, because it's already a rhombus if all of those are 1 meter, and then if it holds true to a property of a rectangle, it'd be both of those things, making it a square. So how could I find the length of that diagonal? And there's actually a couple different ways you can use the Pythagorean theorem to do this. One thing you could do is you could look at like this right triangle here, where the sides are 1, 1, and let's say that this whole side here is x. So I could set this up: 1 squared plus 1 squared equals x squared, or 2 equals x squared. That would have to be the square root of 2 meters. And you could just leave it like that. You wouldn't necessarily have to change that. If you did want to change it to a decimal, I believe it's about 1.4, and you could just include the units on that. Let's do one more example. I draw in the diagonals again, and I'll just put some letters on here: A, B, C, D, and let's put point E in the middle. Well, if I tell you that DE is, let's say, 10, and I want to find the length of AC, well, what I could do is I could know that these diagonals bisect each other, so that would make this 10 also, but then those diagonals are also going to be congruent. So this whole length here would be equal to 20. Okay, we're going to wrap up this section by just helping you guys out. I'll show you how to prove what type of parallelogram it is. If you can show that the diagonals are perpendicular, so show diagonals are perpendicular, then it would let you know that the shape has to be a rhombus. It wouldn't necessarily tell you it's a square. It might be a square, but it would just allow you to say that it's a rhombus. You'd have to do something else to show that it's a square. The next one, if you could show that the diagonals bisect the angles, and I'll write the opposite angles. If you have information for that, that would also allow you to say that the shape is a rhombus. And then for the last type, if you have one pair of consecutive, remember consecutive means they're just like right next to each other, sides congruent, then that lets you know that is a rhombus also. All of these things you would have to know that it's a parallelogram first, because otherwise this wouldn't be enough information for anything. But if you know it's a type of parallelogram to begin with, and you know these different things, all of these would let you say that it's a rhombus. I think we've already done the different properties of a rectangle. And let's just add, I know I kind of don't have a lot of room, but maybe you can just add this off to the side or something. If a shape is both a rectangle and a rhombus, so you could look back to your notes from yesterday for the different properties that make it a rectangle. Usually that's just showing, though, that all of the angles are right angles or that the diagonals are congruent to each other. So if you have both of that, if you have one way to prove it's a rectangle and one way to prove it's a rhombus, then you can say that it is in fact a square. Okay, and then down here at the very bottom is just a way to summarize these different types of parallelograms. There's the general parallelograms like this one here and that one over there. And then within that you have different types of rectangles, and a square is within that category of a rectangle. And you have different types of rhombi, just the plural of rhombus, and you'll notice a square is also within that category. And then the square would be both of those things. So we'll practice examples like this. Keep in mind you'll use the Pythagorean theorem a lot, and probably the one out of these that you'll need the most is remembering that the diagonals are perpendicular, and then you have that right angle there in the middle. So we'll work on this in class, and I hope you find this helpful.